Welcome students. Today we'll be discussing ultraviolet and visible spectroscopy. And today's topic is Woodward fieser rules for calculating absorption maximum in alpha beta unsaturated carbonyl compounds. In the previous video we discussed Woodward fieser rules for calculating absorption maximum in dienes. So I would request you to just please go through that video. Woodward and Fieser framed certain empirical rules for estimating the absorption maximum for alpha-beta unsaturated carbonyl compounds. The rules were later modified by Scott and are as follows. The basic value of alpha-beta unsaturated ketone is taken as 215 millimicron. The alpha-beta unsaturated ketone may be a cyclic or six-membered. For a compound, double bond CHCOX basic value is 215 millimicron if X is an alkyl group. If X is equal to H, basic value is 207 millimicron. If X is OH or OR, the basic value is 193 millimicron. If the double bond and the carbonyl group are contained in a five-membered ring, cyclopentanone, then for such an alpha-beta unsaturated ketone, the basic value becomes 202 millimicron and the intensity for such compounds are generally above 10,000. Then next is the structural increments for estimating lambda max for a given alpha-beta unsaturated carbonyl compounds. Now for each exocyclic double bond, it is plus 5 millimicron. For each double bond, endocyclic in 5 or 7 membered ring except cyclopentanone, it is plus 5 millimicron. For each alkyl substituent or ring residue at the alpha position, it is plus 10 millimicron. At beta position, it is plus 12 millimicron. At delta or gamma or higher position, it is plus 18 millimicron. For each double bond extending conjugation, it is plus 30 millimicron. For a homoannular conjugated diene, it is plus 39 millimicron. Now let us see the table. So here there are increments for various chromophores in the various alpha, beta and gamma, delta or higher positions. So just first one is when the chromophore is OH group. Now see the increments. At alpha position it is plus 35. At beta position it is plus 30. At delta or higher position it is 50. So now you can see in the first column the various chromophores are written, and then in the respective the other columns the increments at alpha, beta, gamma, delta or higher positions are written. So just have a look. We'll be using the rules, the structural increments and this table in the examples which we will be discussing in the later part of this video. So now making use of the above rules, which one? All these three. First is this, second is these are structural increments, and the third is the table. This table in which there is the chromophores are written and the alpha, beta, gamma, delta, etc. positions, and the values are written for the increments at respective positions. So now we'll make use of all these three tables basically, and we'll find out this absorption maximum for various alpha beta unsaturated compounds. So now first see example 1. Calculate lambda mix for the given structure. So here the basic value is 215 millimicron. Then next is see the alpha position and the beta position, and at beta position you can see two alkyl substituents. So I have shown it by the help of two arrows. And just see the table. In the second table we have written here for each alkyl substituent or ring residue, at alpha position the value is plus 10, for beta position it is plus 12, and for gamma or delta or higher position it is plus 18. So here it is at beta position alkyl substituents. So the value is plus 12. Now two alkyl substituents are there at the beta position. So it is 2 into 12. So it becomes 24 millimicron. So now the calculated value is 239 millimicron. The observed value is 237 millimicron. So this is a very simple example. Now see the next example. Calculate lambda mix for the given structure. So here again the basic value of alpha beta unsaturated ketone, it is 215 millimicron. Now see I have written the positions also, alpha and beta positions. So again you can see at beta position two ring residues, I have marked them by arrows. So the value is plus 12. So again it becomes 2 into 12, that is 24 millimicron. Now here there is one exocyclic double bond also. So we have discussed the exocyclic double bond, homoannular dienes, heteroannular dienes, and all these in Woodward fieser rule uh, part 1, that is for dienes. So just go through that video to understand exocyclic double bond, endocyclic double bond, homoannular dienes, heteroannular dienes, etc. so that you are able to easily understand how to see them. Well, here I have written for so that you can understand. So for one exocyclic double bond, it is plus 5 millimicron. So the calculated value is 244 millimicron and the observed value is 241 millimicron. Now let us see and understand the third example. Calculate lambda mix for the given structure. And here you can see, well, the basic value for the alpha beta unsaturated ketone is just the same, 215 millimicron. Now here you can see OH substitution at alpha position. So we have seen in the table, here you can see the OH at alpha position, the value is plus 35. So we have seen in the table and we have written it here. The OH substitution at alpha position, the value is plus 35 millimicron. Now next comes, see the beta position. There are two substituents. One is the alkyl group and one is ring residue at the beta position. So now the value is plus 12 for alkyl substituent, and for one ring residue also it is 12 millimicron. So just add on them. So the calculated value is 274 millimicron and the observed value is 275 millimicron. So by the I have shown it the alkyl substituent and ring residue by arrows, so you can clearly understand. Now next example is calculate lambda mix for the given structure. So here the basic value for alpha beta unsaturated ketone is 215 millimicron, and you can see alpha, beta, gamma and delta positions. Now see the alpha position first. So there is a ring residue At alpha position, I have shown it by the help of arrow, and the value is plus 10 millimicron. Now then, next see the delta position. There is one ring residue at delta position as well, and the value is plus 18 millimicron. Then next is, you can see one exocyclic double bond. So I have written in the structure that also, and the value is 5 millimicron. Then there is one homoannular conjugated diene. That means the conjugated double bonds present in the same ring. So you can see in the ring B, and the value is 39 millimicron. Then you can see one double bond extending conjugation in ring B, and the value is 30 millimicron for this double bond extending conjugation. So our calculated value comes out to be 317 millimicron. And the observed value for the structure is 319 millimicron. So I hope by the help of all these examples which we discussed here, the Woodward fieser rules for calculating absorption maximum in alpha beta unsaturated carbonyl compounds, they are clear to you, and now you can easily make use of the above rules and calculate the absorption maximum for the various alpha beta unsaturated compounds. So please try to solve some more examples. Thank you so much.